Hey there. A quick follow-up. If you haven't watched the Sharpie and paper video that I've published that talk about the power of two, you should watch that before we look at what I'm doing here because I'm going to illustrate a couple things here. One of the things that I said in the video was that the common data type for an integer is 32 bits. And it certainly used to be that way. But now that there's a lot of 64-bit systems out, and even in cases where there's not 64-bit systems, programming languages have adapted to give you bigger data types by default. So I want to show you a couple things in Python here, and then I'm going to show you a couple other programming languages to kind of help close the circle here. So I have my Python interpreter open here, and by now you've kind of learned how to do some basic math, right? So I could say, I can say a equals 10, b equals 20, and I could say print a plus b. I can subtract them, I can multiply them, and I can divide them. I can also use what's called the mod operator here. And so let's say that I say c is equal to 3, and I print b%c. What that does is it takes b and divides by c. So it takes 20 and divides by 3. And it tells me what my integer, if I do an integer divide, what my remainder is. So 20 divided by 3 is 18, or sorry, is 6 point something, right? Because 6 times 3 is 18, and it leaves me with a remainder of 2. The mod, this is called the modulo, right, is where this sign comes from. And it's pretty commonly used to catch remainders as you're doing math. And in fact, you'll use it pretty early in this class. But I also want to show you how to do the power, the exponent command. So if I do, let me set a to equal to 2, and I do print a and I do double star, a to the power of 2, that should give me 4. If I do a to the power of 10, that should give me 1024. And so the double star in Python is the superscript. It's a to the power of. Right? So now let's see what happens here if we try to illustrate some of the things we were doing in the video. Remember, a to the n is equal to a to the a plus b, or I shouldn't use a again. A to the x plus y is equal to a to the x times a to the y. Same answer, right? A to the 30, 31, 32. So it works. Actually, in Python, the current version of Python handles numbers that are bigger than 32 bits. And I said most languages aren't able to handle that in the default data type. But Python is. And that's what basically the version of Python version 3 or 3.7, which is what we're using. Let's keep going. Let's see how... that number, I have it written down. Yep, that number matches our kind of our rice puzzle number, right? See if we can go fast further. Okay, so Python is able to go quite high, which means it has some built-in capabilities to handle big math. Okay, so that's good. You're not going to run into overflow problems if you just kind of use default stuff. By the way, there are additional libraries that you can download in Python that give you the ability to force 32-bit data size. Let me show you 2 more programming languages as an example. Let me bring this over. This window is what's called running a language called Lisp, Lisp, and I'm running this inside this programming environment called Emacs. And there'll be a few of you, my guess is in this class, that goes, oh, I've heard of that, or maybe I've used that before. But it's just another programming language that could be used, and it has a different syntax. Basically, you put things inside parentheses, and you do what's called prefix notation, where you put the operator first, followed by the operands in order, and you have parentheses around them. Okay, so expt is the power of command. So 2 to the 8th is equal to 2 to the 6th. So let's try that with some bigger numbers. 2 to the 10. 2 to the 20. 2 to the, let's do 2 to the 26. Okay. 2 to 30. Uh-oh, I got a problem there, right? So that's not working, right? So let's see if we can figure out where the limit is. Let's try 2 to the 27th. Okay, that's equal to double 2 to the 26th, so far so good. And then 2 to the 28th gives me a negative number. So in Emacs, unless you specifically compile the program in a different way, it only has 28-bit integers, which means my highest number that I could support is 2 to the 28th minus 1. Right? So if I try to do 2 to the 28th, I get an overflow. Okay, so here's an example where I don't even get 32 bits. Very few people program in Emacs Lisp compared to other languages. It just happens to be a language that I know relatively well, and I use Emacs still a lot, even in a Windows environment. Let me show you a language that is very commonly used, and that's C++. Okay, so ignore all this stuff. Some of you have seen C++ before. When I teach CS160 in the fall, I get usually 4, 5, 6 students that take CS161 with me in the winter. But I only teach 161 in the winter, so I don't necessarily see my spring term students. Or if I'm teaching CS160 in the winter, I won't necessarily see them in the spring. But I've declared an integer and called it a, and then I'm using the pow function, or the power function, to go 2 to the 30th, 2 to the 31 minus 1, and 2 to the 31. So if I run this, let's see what happens. I get 3 numbers. I get the approximate 1 billion number, the approximate 2 billion number, and then I get a negative number. So C++ is true to that 32-bit limit if I use the int data type. So I said in the video most programming languages, and then I just showed you 3 programming languages that have 3 totally different behaviors. So just something for you to keep in mind as you develop. Big numbers can be very, very problematic. And I will say in CS160 that unless I specify otherwise, you don't have to worry about testing for overflow because I won't use these massive numbers, right? I'm more interested in you recognizing data cases that are more, kind of more common. Like, well, what happens if I go below 0? Or what happens if I'm exactly 0? Or etc. So let me know if you have any questions about this, and I would encourage you to just go ahead and please try and please play to get more of a feeling on how this stuff works.